Good morning, everybody. Thank you for making the trip all the way upstairs for this session. I'm Michael Webster. I'm one of the R&D engineers from Nutanix. I'm based in the eastern island of Australia. You may have heard of it, sometimes known as Middle Earth or New Zealand. I run a global team that's specifically centered around engineering our platforms for business critical applications. So who's familiar with Nutanix or has spoken to us on the booth? Excellent. Fantastic. So I'd just like to do a quick survey to figure out what sort of content you're more interested in, and then we can start with a slide deck. But given that we have an intimate audience, we can probably customize things as we go. So who's interested in Azure Pack? Yes, excellent. Good, good. What about Exchange? Okay, no Exchange. Wow, we can skip through that pretty quickly then. What about SQL Server? And live demos? Okay. Who wants to see behind the scenes of some of our support infrastructure and analytics across all the platforms that we monitor across the globe? Okay, bit of that too. Excellent. So what we're going to talk about today is how Nutanix is making infrastructure invisible for Microsoft environments. So specifically centered around those applications that I mentioned, SQL Server, Exchange, and Azure Pack, and how we're making it easier for anybody to deploy infrastructure. So you don't really need any specialized skills anymore to run a Nutanix platform. It's so simple, even an 8-year-old can do it. And I know that from personal experience because my 8-year-old son is the world's youngest Nutanix certified admin. So if you want to know how easy this thing is to run, just look it up on Twitter. Okay, so Nutanix is a company that was founded in 2009 from engineers that came from Facebook and Google. And they saw an opportunity because it's very easy to do things at massive hyperscale like you do in those web scale data centers, but there was nothing really around that any organization could take and use that gave them the same benefits, the same economics of a cloud, but running in their own data center. So Nutanix has had a pretty rapid growth curve over the last 5 years, to the point where we're now the leader in the Magic Quadrant for Gartner for all integrated systems, and the most visionary as well. So we're up there with the best of the best, with the Dells of the world now, and everybody else. And we provide software that is packaged with hardware so you get a consistent and predictable experience for any application. So why Nutanix? And why do we want to make things invisible? Well, I think you probably agree that infrastructure shouldn't be as complicated as what it is. It really is complex. Even the converged infrastructure solutions are pretty complicated to set up, and they're complicated to scale and to manage. So we want something that just works, that removes constraints, and also eliminates guesswork. So you want to eliminate guesswork in the infrastructure, but my team also wants to help you eliminate guesswork in the applications. So we spend a lot of time developing best practice guides, reference architectures, and things so that you can take the time and the risk away from deploying applications on the infrastructure. We want to take the traditional 3-tier architecture and collapse it down into something that's modular, and that is a building block approach that can scale as and when you need, so that you don't have to buy everything up front, you just buy what you need, and the infrastructure is delivered on demand. Now this sounds very much like logging into Azure and spinning up virtual machines and spinning up storage and everything capacity on demand. Basically, we allow you to do the same thing, but in your own data center, and then we give you integration with Azure and the public cloud as well from our platform using our management tools. But so that you guys don't get locked into any one way of doing things, and you have the control. And we use web scale technologies to do this. So our whole platform, our original engineers came from Google. They developed the Google file system. They came from Facebook. They developed Cassandra for Facebook. We have our user interface designers came from Apple. So we've basically got a mix of some of the really cool tech companies in Silicon Valley that have come together to build this platform that can start small for any sized organization and grow to massive scale. And here it is. So this is our little box. There's a 2U. You can get up to 4 nodes in that 2U, 2 terabytes of memory, 96 CPU cores, 16 terabytes of storage, usable. That's before any fancy dedupe, compression, or anything else that we do in the box. So that is just a bonus in our way of thinking. So we can collapse the complete server and SAN that we have today, and you just need this and Ethernet, and then you just add boxes as you need to grow. And it's as simple as that. Now the process of adding a box is there's a button in the interface that says expand. You click that button, and it expands. So it's a platform that we can set up in minutes. You can upgrade non-disruptively during lunchtime, and I'll show you a photo of a customer that did exactly that at scale. And then you can go home early because it's built to self-heal. So you're not going to get a call at 2 o'clock in the morning saying, hey, you've got to come in and fix something. That's the idea. Because Google doesn't go into their data center at 2 o'clock in the morning to fix a failed disk or to fix a failed node. They roll in a rack of equipment every week to fix the failed components that have failed during that week. Because their entire platform is built to self-heal, their software is built knowing that hardware is going to fail. And we've used the same premise for building our system for an on-premises cloud environment. So from a technology perspective, so if you're interested in the bits and bytes and how it actually works at the back end, so we combine compute and storage together. We have a hypervisor, and this can be Hyper-V, and we have a controller virtual machine. That is your storage controller. It runs on every single node in the platform, and that's how you get linear scalability and predictable and consistent experience every time. So once you know how much performance you're going to get from a single node, you get exactly the same as you grow, as you need to. We include both flash and hard disks. We can do snapshots, clones, compression, deduplication. That's all expected. That stuff just works. The benefit of having flash is pretty obvious. Your applications get massively accelerated from an I/O perspective. Your virtual machines sit directly next to the storage controller. So if you're running a SQL Server database, it has direct access through memory to local flash. So that's the lowest latency you can get. Now for data protection, obviously we have to distribute data across the cluster. That's done in a distributed fashion across every single node in the cluster, and we always write to persistent storage, and we always checksum everything we write so that you know you're getting back the data that was originally written. So we take data protection as our number one priority over everything else because we want you to have a consistent experience when things fail just as well as when things are running well. And there's no limit to how many you can scale other than practical limits. You'll run out of space in your racks, you run out of power that you can get to your racks and that sort of thing. Or you'll run into, you're going from layer 2 to layer 3 at the top of rack switching. So there's practical limitations, there's no limits in software. Our biggest customers running 1,500 nodes in production, no problem at all. And they started from just 3 nodes. So our biggest customers started with just 3 nodes to dip their toes in the water, and then they just grew it over time as they needed to. And so you can start small, scale incrementally. So if you've got a project-based funding requirement where a project buys a bit of infrastructure, they don't have to buy a massive rack full of infrastructure. They might just have to buy 1 node, 2 nodes, however many it is. And then those can scale out, and as we said, there's no limit. Now, capacity in terms of storage and performance scales the same when you add a node. So what about Microsoft private cloud environments, Azure Pack? We're making that invisible as well. It's not quite as invisible as what we'd like it to be, but we're getting there. We've got a Microsoft certified reference architecture for Azure Pack on our platform. So it's really a turnkey private cloud solution with Hyper-V. Linear scale, because that's the way the platform is built, so that you know exactly what you're going to get every time. And we leverage things like the Azure Pack, PowerShell, and a SCOM management pack as well. So I'll show you some of our SCOM commandlets later, and I'll show you some examples of using PowerShell to provision some virtual machines as well. So again, we can start from 2 rack units and we can grow as we need to. And this is what it looks like. Has anybody deployed Azure Pack before? Okay, so it's deployed in a pod architecture. So you have a control pod and a services pod, which we'll get into. And then you can scale those pods as your needs grow. So for even a large-scale organization or a cloud provider, essentially they could use Azure Pack in their own data centers to give you an Azure-like experience, but it's more under your control, and then you can integrate back into the public Azure version as well. API integration, Fast Track certified for Microsoft support, all running on Windows Server 2012 R2 with Hyper-V. And this is what it looks like. So, availability zone is probably a term you're familiar with in the public cloud. So you build an availability zone by matching a control pod with one or more service pods. And then you can scale out the number of service pods that you need. And this is our control pod. So the control pod runs Windows Azure Pack, and it runs all the infrastructure services, and it runs the integration services for that environment. So in a large-scale environment, this would be a dedicated Nutanix cluster with probably a couple of nodes just to run the infrastructure virtual machines. And then your compute workloads would run in the services pod, and they have dedicated direct access to all the resources in the services pod, and then you can dynamically deploy systems and destroy systems on demand. So this is what a services pod would look like. Now this is just an example. The number of hosts and the number of clusters can be customized to what your requirements are. But you might choose a pod design like this, so you're just rolling out a rack at a time. So you keep it nice and small and very easy to manage. So in the services pod, we have SCVMM, we have the SCVMM host clusters, we have the Nutanix clusters, all the services and resource providers that we need to run all the virtual machines, all the application services that are going to be in this environment. Now here we have an example of a single availability zone, or what a single availability zone might look like. Now, you probably would start off with, maybe just 3 hosts in total in a small environment, and then you just grow it as you need to. So you don't need to build the whole thing up front. You can do it as your needs grow. And then if we go into a bigger environment where you've got multiple availability zones distributed across a geographic distance, this is an example of what that would look like. Now still, the installation of all of these different components today is up to you guys. It's manual. Now in the future, Nutanix is going to be doing this for you and shipping it pre-configured from the factory, already ready to go. So you can just run it up in your data center and you have an entire Azure Pack cloud ready to go in minutes from the time that you place the purchase order. It'll probably be a few days, say 15, 20 days. So that's going to rapidly reduce the amount of time it takes you to get business value back to your end users. Now we also have direct integration from the Nutanix management frameworks into Azure for backups. So even if you're not running Azure Pack, if you're running any other workload on any of your environments, you can do backup back to Azure, and then you can recover that back to your own data center. So at the moment, it's purely for backup and recovery. In the future, we'll also enable the capability for you to recover those virtual machines to Azure, and we'll do the virtual machine format change on the fly. And it doesn't matter which hypervisor you're running in your data center, you'll be able to recover those virtual machines to Azure. So again, we're giving you guys the choice. You get the control of what you want to do when you want to do it. Everything is VM-centric, so we're looking at the components of a virtual machine or a group of virtual machines. So if you've got an application stack that has web servers, app servers, database, then you can take that as a single protection domain and replicate that up to Azure for data protection purposes and recover that at the same time, and it's a consistent package, so a consistency group essentially. And it's all integrated into our user interface, which you'll get to see in a few moments, WAN optimized, because last time I checked, we didn't have completely unlimited free bandwidth to use to the cloud, although the cloud extensions are pretty good, especially on the eastern side of Australia or the eastern island of Australia. We don't have bandwidth for free, so making sure that's optimized is very important. Okay, now what's under the covers? So we spoke briefly about this a few minutes ago. So we have our hypervisor, we have a piece of hardware. We do direct access to the SCSI controller for the controller virtual machine, and it directly accesses the hard disks. The user virtual machines directly access their local controller, and they have, for read I/O, they have direct access to local SSDs. Now the size of these can be configured to your requirements, so there's no fixed size. And then that scales out as you add nodes. So if we compare that to a 3-tier architecture environment, when you buy the brand new servers, brand new switches, brand new SAN, the first day is the best day in the world. Everything is running perfectly. It's very easy to manage. Now over time, it gets harder to manage, it's harder to change, things degrade, including performance. In a web scale environment, the worst day is the first day that you deploy it. Because from that day forward, everything should always get better. Every time you add a node, you're going to get more capacity and more performance. Every time you do a software upgrade, you should get more features and more performance. So if we take a comparison of some of our customers that invested with us 4 years ago, they maybe got 20,000 IOPS out of 4 servers. Today, they're getting 80 to 100,000 IOPS from the same hardware just by upgrading the software. They don't have to change hypervisor. They don't even have to change hypervisor version. They just do a single one-click upgrade during their lunchtime or while they're having a coffee, and they get more performance out of the same platform. Or more capacity, because recently we enabled a feature where our existing customers get another 30% additional capacity on the same hardware. Now, when's the last time your existing vendor gave you more performance and more capacity without buying anything new from them? Think about that. Okay, so we have our distributed file system, very similar to the Google file system. We have SMB3, so this is the way that we present virtual machine or the storage to virtual machines in a Hyper-V environment. And then we have our SSDs, our HDDs, and also cloud storage connected into our infrastructure. And then we've got all of the built-in features that you'd expect. ODX for offloads, REST APIs, so the developers can programmatically access the infrastructure and they can control it through their development tools if they wish, if you allow them to. So they can spin up and tear down virtual machines on demand. So if you're using something like Team Foundation Server, you can do a build and it can automatically go and spin up all the virtual machines that you need to test it. Once the testing's complete, tear them all down again and start again. But you're always getting back to a completely consistent point every time. So you're able to deliver higher quality code to production with less defects. HTML5 user interface. So if you bought a new Tesla, you could run the Prism user interface on the Tesla console. We've seen people do that before, just as we've seen people do upgrades from aeroplanes. We have lots of PowerShell commandlets. So if you don't want to use REST APIs, you can just use PowerShell to interact with the architecture as well. So most of the things that you can do through the REST API, you can do through PowerShell. Our user interface, which is HTML5 based, completely uses our REST API. So there's nothing like, there's no hidden interfaces, no hidden APIs. Everything you see through our user interface, you can do yourself if you're so inclined. Okay, let's quickly go through Exchange, because I know there wasn't anybody really interested in Exchange, because everybody's running an Office 365, right? Yeah, exactly. Well, we are, so we understand. We do have a lot of customers using Exchange. So Nutanix aligns very closely with the Microsoft best practices, but we do things slightly differently. Okay, so with a preferred architecture, if you've been to an Exchange presentation, you're probably aware, physical servers, local JBOD, turn off the data integrity features for your log drives, because that sounds like a good idea. 4 DAG copies, and you use the DAGs exclusively for HA. So you've got to manage all the physical servers, the compatibility matrix, the firmware, the drivers, etc. is all on you. Sounds great, especially when you've got thousands of servers. Excellent. So we use our own resiliency to not only take advantage of the capabilities of Exchange with DAGs, but to provide additional data protection at the infrastructure layer. So we do use the JBOD storage because we've got the local disks, but it's in a distributed architecture. Virtual machines, choice of hypervisor. All of the hypervisors are certified to work with all Microsoft applications, so there's no question about supportability. 2 DAG copies plus the additional data protection that we offer at our layer. So you can do 2 DAG copies but get the data protection of 4. Now the advantage of this is if a component in the platform fails, the virtual machines don't know. So you don't have to reseed databases or anything like that. And then we use the DAGs plus the hypervisor protection for high availability. So if any node fails, then the virtual machines are going to restart. So this is a very quick process. You don't have to wait until your hardware is replaced to get your system back up to 100% performance. Sizing, exactly the same as physical. Nothing changes here. Follow Microsoft best practices. Simple. But what about if your mailbox server requirements grow? Now, if you're running in a physical JBOD environment, let's say you maxed out the configuration, you've got to basically put in another server, you've got to migrate all the mailboxes across, you can't expand the amount of disks or the amount of storage. In a Nutanix environment, all of the storage is pooled. Every virtual machine has access to all of the storage. If you want to add more storage to a virtual machine, you just add another virtual disk, a VHDX, and then you just grow it as you need. So there's no limits in terms of what you can put on a single Exchange virtual machine. If you need more storage, you just add more storage to the virtual machine and you grow. You don't have to migrate mailboxes or anything like that. So this is how it'll work. So we've got 30 terabytes in this example configuration here. And if we want to add more storage, we just add a storage only node. So this is our preferred Exchange platform plus a storage only node. You get 49 terabytes. And that's probably a good size for a mailbox server in a large environment. Or you could just have very large mailboxes, 20 gigabyte mailboxes per user or something like that. And then you don't have to worry about archive and all these other things going on. Now we do have an ESRP, which is the Exchange Certification Program for vendors. That's 24,000 1 gig mailboxes with 3 Exchange virtual machines per site. So 6 Exchange virtual machines in total. And that takes up 8 rack units per site. So 8 rack units per site, you get 24,000 1 gig mailboxes. And that will scale linearly. So if you want to do a pod-based architecture, you want to add, say, 48,000 mailboxes, 96,000 mailboxes, you just add nodes to grow it out. Add mailbox servers as you need to grow. Now, because the way we do the data protection and the way that we put the Exchange virtual machines on our platform, you can use less Exchange virtual machines and get the same capabilities. Less Exchange VMs means less license costs. The same thing works with SQL. Always on availability groups and things like that. And you can provide complete data protection between sites. Even if a complete Nutanix cluster was to fail, your databases are still going to be protected. Okay, we've gone through that a bit. Let's get on to some SQL Server. So non-disruptive hardware upgrades, migrations, no forklift upgrades ever, no silos, standard platform, less hardware, hypervisor agnostic, all of them certified. Our ESRP was tested on Hyper-V. We're also doing an ESRP on our particular hardened version of a hypervisor based on KVM as well. Okay, SQL Server. Now everybody interested in SQL Server, I hope. So the benefits for SQL Server depend on the type of database that you're running, whether it's a data warehouse or whether it's a transactional system. Transactional systems benefit from the fact that we have local flash and we can do very, very low latency transactions, and that we can separate the I/O streams between the transaction log, which is sequential, and the data files, which are random. So in most storage platforms, the storage processor sees everything as completely 100% random and it's just a jumble. So they can't do the difference between the transaction logs and the data files. We can, because our controller virtual machine understands every virtual machine, every virtual disk. Now that's provided you lay out your databases and you separate those different components. So the transaction logs on one disk, the data files on another disk, for example. For data warehouses, we have a lot of I/O performance in terms of sequential read and write per node. So some all-flash platforms, for example, have trouble handling sequential I/O. We don't have any trouble handling the sequential I/O because we have the mix of flash and also hard disks. In some platforms, we do have all-flash, but the way our controller virtual machines are designed is to give you throughput and low latency transactions. So an average node, like a small one, not our largest ones, could probably do 500 megabytes a second of throughput. Our larger ones can do a gigabyte a second of throughput per node. As you expand, you get more. A single 2U box is about 100,000 IOPS if you're interested in I/O performance. And then again, as you add more boxes, you get more performance. So here's some of our best practices. So separating the OS, the database, and the logs. Everybody should be doing this as a SQL DBA anyway. Using the integration with VSS snapshots, understanding the I/O needs. So we have built-in snapshot replication capability in our platforms also. You can use, if you've got Enterprise Edition, some of the advanced functionality around object and row and page compression and things like that. We can do failover cluster instance if you've got standard edition licenses, but the preferred way of doing data protection for SQL is always on availability groups. Now that also gives you the most flexibility because then you can take a replica of your database and put it in Azure or in another place. It's very flexible on how you provide your availability for your database platforms. For Hyper-V environments, use Generation 2 VMs. For VMware environments, make sure you're using ParaVirtual SCSI and splitting those disks across the different SCSI controllers. And that will give you the best performance. Okay, This is one of the best use cases for a Nutanix environment, is not just production, but also for all the dev test environments that you've got. You want something that's predictable, that's production-like, that's consistent, and that can be spun up in seconds. So this is where we actually get into some demos. So first, let's have a look at Hyper-V, and we'll do a comparison between doing the traditional cloning methods and also using Nutanix fast clones. So we're going to take a standard clone using System Center Virtual Machine Manager of the source virtual machine, which could be a 500 gig SQL Server database. It could be any type of virtual machine that you've got in your environment. Give it a name. These are the standard wizards that you'll go through. So this one's got a 40 gig disk. It's only using 8 gigs. So we'll kick off that process, choose the hosts. So we've got 4 hosts in this cluster. Choose one of them. That's the storage location. So all the storage locations are just SMB3 shares. So they're all presented to the hypervisor automatically. So if you created a new container in the Nutanix environment, there's nothing you need to do on the hosts to make that available. It's automatically available. Now, one of the other benefits of the Nutanix environment is, say today you bought it, and 6 months' time there is a new processor that comes out from Intel, and Nutanix has a new node that comes out from Intel. You can immediately take advantage of that new platform and mix and match to your existing environments. So you don't have to wait 3 or 5 years to get the new flash performance, and then you can just live migrate your systems over to it. So all these forklift upgrades that your infrastructure teams or you guys have gone through in the last number of years are completely eliminated once you're in this new web scale environment. Okay, so we've set off that clone. That's going to keep going. Now we're going to do the Nutanix fast clone. So this plugin's available for any Hyper-V environment using System Center Virtual Machine Manager. Just like our SCOM management pack is available if you're running System Center as well. You can just download the management pack. So we're using 2 accounts. One is going to integrate with the Nutanix APIs, and the other one's going to integrate with VMM. Okay, so we're going to choose the storage location. We're not going to power on the virtual machines, so this is going to create 5 copies. Now this is all a PowerShell script in the back end, so you could just run this PowerShell script directly against System Center Virtual Machine Manager. Or you can use the wizard if you feel inclined. We'll click Create. Now bear in mind that this other clone is still going on in the background. It's still tuning through, doing a clone of that one virtual machine, which is at about 50% at the moment. And we're done. So we've just created 5 clones in a matter of seconds. We just go to Hyper-V Manager. Here are our clones now. So that was quite a bit quicker. Now that process can be completely automated. The number of virtual machines can be as many as you like. The size of the virtual machines can also be as big as you like. So what we're going to do now is dive into a live environment. Hopefully the demo gods are going to smile on me today. Now this is, we're transporting ourselves over to the Eastern Island where my lab is based. Okay, so this is the Nutanix Prism interface, HTML5. We have a health check view on the front page. Now this is where all the telemetry data that we collect across the platform is presented to you if there's anything going wrong. So we're running hundreds and hundreds of health checks across the environment at all times. So if any particular component has a problem, you'll know about it. But also more importantly, our support team will know about it proactively as well. So that if we see like a disk is beginning to fail, we'll ship you out a new part so that you can replace it before that happens. We also have a performance view on this page where we can see the number of IOPS going across the cluster latency, CPU usage, and memory. So because it's an integrated system, we know about every single virtual machine. We know about what the memory utilization is. We know what the storage performance is, what the network performance is. We also know how many CPUs are being used and what the performance is of that on the single platform. Now if we go and look at storage, So we've got compression enabled. I've got a bunch of databases on here. So we're saving 1.8 to 1. So we're saving almost 50% of our storage because of using compression inline. Now I can also, through this interface, see all the virtual machines that are in this environment, regardless of the hypervisor. And at this time we can see that we've got a SQL Server database down here. It's got a bunch of virtual disks. I can see what the performance and size of all those virtual disks is. I've got a whole bunch of additional stats, so I can see how much of the I/O is random, where is it coming from, how much is read, how much is write, all in this one place. So what we'll do, this is our template here. So it's 400 gigs, that's already got a pre-configured database in it. Let's create some copies of that. Okay, so I have a PowerShell script. Now this PowerShell script is going to run through, and it's going to use the Nutanix and the APIs to create 12 copies. Oh, hopefully it works. Otherwise I have another way of running it. Okay, it's not going to work this way. We'll do it the other way. Just looks prettier on this integrated development environment. So this will do the same thing. Go through, create 12 virtual machines, power them on, customize them, change the power management settings inside of Windows to be high performance. It's going to also check the network card settings, optimize those for performance. It's going to go through, check the disk layout and everything is correct and optimize that for performance as well, all from this base template. And it really should be fairly quick regardless of the size. So we're going through creating those 12 virtual machines now. Some of them have already finished and they're starting to be powered on. We'll just wait until all of them are powered on and then we'll log in and see how long that takes to boot. So if we go back to our management interface, if we go to the home screen, we can see how much storage is used. Now once the cloning process is finished, we'll come back and check how much storage is used. Okay, so the cloning process is now finished. We have 12 500 gig databases stood up. If we open the console, we can see that it's still booting. If we go back to our management interface, it's still using exactly the same amount of storage. Now that is not dedupe. That's not even benefiting from compression. This is just intelligent data avoidance. We know that it's an existing virtual machine. We know it's the existing data. We don't bother creating new data. We just point back to the original copy, and then it's only when you start writing new things to the database, you start running your tests, that's when it starts consuming the storage. So if you're a dev test environment, you can run up an unlimited number of virtual machines, provided you have the physical resources available to manage them, without using any additional storage capacity. And then on top of that, you can benefit from dedupe, compression, etc. in addition to this. Okay, so that virtual machine's booted, it's going to go through, it's going to get customized, and all of those post-process scripts are going to run. Now, because we support multiple hypervisors, and you've already seen Hyper-V, that was using VMware for SQL Server. Nutanix has also got a hardened distribution of KVM, which we call Acropolis. Now, this is certified under the SVVP program to run all Microsoft apps. And we can do a similar sort of process with this. So it's the same interface across all the hypervisors again. And we have another 400 gig database virtual machine that, like on any good cooking show, we prepared earlier. And we can do the same process with this, but this time I'm directly using the Nutanix APIs, running a script. So we're going to go through the same process. We're going to create these 12 virtual machines. We're going to power them on. We'll do all the post-boot scripts, and then we'll be able to run our test. Oh, okay. So that's done. Took 11 seconds to create 12 500 gig database virtual machines and to power them on. Now let's go and check the console and see if it's booted yet. So it's still booting. So if we give it a couple of seconds, that'll come back with our familiar screen, and there we have our database ready to go. Now again, this hasn't taken up any additional storage capacity. If we go back to our home screen, we can see that that hasn't changed. So what we're doing is we're equalizing the playing field across all the hypervisors, so you guys get to choose what you want to do. Now, if you want to run Azure Pack, the reference architecture and everything's based on Hyper-V, that's probably the best way to go because that's where everything gets integrated. But let's say you've got another platform already in your data center and you want to have the same capabilities for some of these types of use cases. We're allowing you and giving you the tools to be able to do that. We're also giving you the tools to be able to go to the cloud and back and go between clouds on a whim, essentially, as and when you need. Now, if I wanted to destroy those virtual machines because the testing is complete, I've got another script that goes through and it removes all those virtual machines. But I know that next time I can always get back to the same place. And it's only going to take me 12 seconds or some number of seconds to stand up those test environments. Now, what about if you've got lots and lots of different clusters all over the world? Oops. So before I was just showing you a single Nutanix environment, but what if you've got 100 Nutanix environments and you've got thousands and thousands of virtual machines? Well, this is where our Prism Central comes in, and you can manage up to 100 clusters from a single screen, get all the telemetry and performance data from that single screen, pinpoint when things are happening, what's going on in that environment, and you can also see when things are being upgraded. So this is just a small environment that I have in my lab, but we've got 22 hosts, 8 clusters. It could be any hypervisor, and you can see all of that from this one interface. You could even have cloud resources visible from this one interface. So this is your central management console for any number of environments. Now, what if you wanted to do an upgrade? Let me just go and grab something. Now, if you're one of the US's largest retailers and you have 142 nodes and 3,000 virtual machines and 11 clusters, the best time to do an upgrade is when? They're running their point of sale systems on this infrastructure. When is the best time for them to do an upgrade? Anytime. Exactly. So they chose 12 o'clock on Wednesday during the lunch hour rush to upgrade their entire infrastructure. Completely non-disruptive. Now, they've done it for a long time. So they've gone through this process many times. They've built up confidence in this process. But this is that environment being upgraded. And this is normal for our customers. This is not abnormal. No longer do you need a weekend change window to do upgrades of your infrastructure, and your applications don't even know that it's happening. Okay, we've still got quite a bit of time left. So I'm going to open the floor up to questions just after I show you one more thing. So I'm going to log into a different system now. I'm going to give you guys some behind the scenes of Nutanix. So now we're going to connect through to San Jose, so we're going back in time. It's like Back to the Future. Because one of the most important things about dealing with any company is not about the sales process, it's about the after-sales process. How are we going to support you? How are we going to look after you as customers through this partnership that you want to be a long-term success? And hopefully this plays nice with me today as well. Here we go. Rightio. Just expand that out. Oh dear, not responding. Recover. Who's seen Windows do this week? Oh, it's coming back. Okay, let's go back here. Right, I'll go to our dashboard. Now, Watchtower is our internal support system that we use to monitor all support requests and all customer environments across the globe. And it's how we track customer service. So whenever a customer rings in with a support request, now a support request is not just with our hardware. It could be anything to do with the hypervisor, it could be anything to do with the hardware, it could be anything to do with the applications running on it. So I had a customer talk to me the other day at the booth saying, we're running Zookeeper on top of Nutanix, who do we call for help? I'm like, you call our support team. I'm running SQL Server on Nutanix and we don't think it's behaving the way that it should do, or we want to get some more performance. Who do you call? You call Nutanix support team. Or something's going weird on the network and it's affecting the Nutanix environment. Who do you call? You call somebody from Nutanix support. The whole idea is because we're a converged infrastructure, we can support everything from the application down to the network, including the hardware. And we've got specialists in our support team, but also in my team and in the engineering team that can help you. So if you're a Nutanix customer and you call us, you get straight into level 3 support, and the next person you talk to is a person that understands your environment or the applications, or the guy that wrote the code. It's a very quick jump from our 3-level engineers, which is your direct line in, to everybody else. Okay, so our SLAs, we're doing pretty good. Now, our average time to answer a P1 is 17 minutes. Our average time to answer a P3 is 21 minutes. Not like other places. Now, at the moment, we're monitoring 37% of our systems across the globe, and our Net Promoter Score is 91. So how that's calculated is after every support interaction, we send a survey, and one of the questions is, would you recommend Nutanix to your friends and colleagues? If you answer yes or 10 to that, then this goes directly to our Net Promoter Score, which is audited every year. And to give you an example of another company, say Apple, Microsoft, they're down in the 40s. So we're up in the 90s at the moment. But what about all of the systems that we've got across the board? What sort of analysis can we find out about those systems? Let's go to product first. Now, every executive in Nutanix has this dashboard in their office, and it's also on screens all around. Now, we have support centers in 12 different places, and we've got engineers that cover the globe. So you get the same 24/7 support that you get from anybody else. You can get 4-hour parts response, but really if the system's going to self-heal, do you really need a part in 4 hours, given that it's not a disaster if a disk fails or anything like that? Just get next business day. So this will take a little bit to load, update all of these graphs. And then we'll be able to see what the availability is. Here we go. Come on, this is the one I'm interested in. Okay, here we go. Right. So right now, our 3-month moving average availability across all the systems we monitor is 99.93. Now that is not just unplanned downtime. We consider an upgrade or planned downtime in this value as well. So every time we do a software release, our customers are pretty quick to jump onto it and do the one-click upgrade, and that's reflected in this number. So even through system upgrades, hypervisor or our storage firmware, we're still at 99.93. Software quality is on the correct trajectory. So across all of the platforms, the number of defects per platform is going down. If we scroll down, we'll get some more data on some of these other systems, but I want to go into disks and things like that. Okay, component analytics. Now, one of the reasons we collect all of this information is so that we can proactively see when things are going wrong across our environments and make changes to improve at all times. We're always trying to make sure that things are improving. Right, okay, here we go. So 1 terabyte hard drives, we have 70,000 that we're looking at. And the failure rate on those is 0.3%. So we understand hardware fails, but it's still pretty low. 4 terabyte hard drives, we have 10,000. Failure rate on those is almost 1%. That's a little bit high. SSDs, this is where everybody's going. So we've got 20,000 of those, 0.39% failure rate. We have a couple of thousand Fusion IO cards out there. Their failure rate's a bit higher than we would like. We don't ship Fusion IO cards anymore because of these sorts of things. And all of this data is monitored across every system so that we can deliver a better result for you guys. Okay. So that's all I have to really show you, unless there's any questions that I can help you with. So has that been useful? Have you learned something today that you think might help? So what questions have you got?
I'm curious about the pulse score, why that was so low. Like, have you got that amount of customers that
About 30% of our customers are federal government in the US. We've got all security certifications for all classifications of network, including NSA, top secret and above. They're dark sites, we can't get any information from that, and a lot of time the customers just don't turn it on. So we do encourage them to turn it on, because the better analytics that we get, the better we can support the customers and make sure the products are tuned to what they need. But most of the reason is because we're operating in such secure environments, including not just federal government, but healthcare and financial services, they just don't send the data. It's against their policies. Now, why did that not come up with the other laptop? Oops, I pressed the wrong button, that's why. Any other questions?
Yeah.
Yep.
Does it make any difference when you're migrating off your legacy systems, whether it's generation 1, generation 2 Hyper-V virtual machines?
No.
And does it make any difference as well, this type of hard disks, whether they're dynamically expanding VHD,
No.
VHDXs?
Doesn't make any difference, but once you migrate into the new environment, generation 2 would be preferred because the performance is a lot better. But we can run both, it doesn't matter. So the migration process is seamless, you don't have to change those virtual machines. You just do a live migration over to the new platform.
And when you bring those in and you're using Hyper-V,
yep.
when you have in your failover cluster manager, and I think you mentioned yesterday, you have your SMB storage.
Yep.
When you bring in another node, does that SMB storage expand, or does it become another storage?
No, the SMB storage will expand when you bring in another node. So those SMB3 shares are just a logical view of the underlying storage pool, and then as you add nodes to it, it dynamically grows, and you get more capacity every time.
And each one of those just appears as another node?
And everyone just appears as another node in Failover Cluster Manager, yep. It's just like any other server would. Yep. We hide all the magic under the covers through SMB and our controller virtual machines.
When ordering Nutanix
yep.
nodes,
yep.
are you ordering as a greenfield site setting up from scratch?
Yep.
Do you pre-install the hypervisor, or is it the customer's responsibility?
So your partner or Nutanix would pre-install the hypervisor that you choose or do it on site, and that's about an hour process from end to end. It depends which hypervisor you choose. We are going to be shortly shipping Hyper-V direct from factory as an option, and we're going to be trying to include other pre-provisioned applications on top of that, but that's not available just yet, but in the next 6 months it will be.
Is it like Core or something?
Yeah, it's Hyper-V Core. Yeah. We have customers that ask, can they do full version of Hyper-V? The answer is yes, we just have to install it especially for you. But your Nutanix partner or the Nutanix SEs that you're dealing with can definitely help you with those. We're looking at it. We're looking at whether Nano would work, yeah, because there's been interest in that as well. Now, I didn't mention in the presentation, but we also have a free version of the Nutanix software that you can download and you can run on desktop or you can run inside of a virtual machine. It's called Nutanix Community Edition. If you want to get access to that, just go and see the guys on the stand and they can give you an access code for it. The only requirements is an Intel CPU and an Intel NIC, one SSD and one hard disk. Now, if you're running it as a virtual machine, you can obviously fool it into thinking that it has those things. But that just gives you access to the Prism user interface. It's not for performance or anything like that. It's just to play around with. But that's available for free as well. Any other questions? Great. Well, thank you very much for your time. Any other questions? I'll be down in either in the Nutanix booth or in the speakers lounge. So you can come down and ask me anything you like about any app, any Nutanix platform or anything, and we'll see if we can help you out. So have a great rest of your day and enjoy the lunch, because I know I was between you and lunch. Thanks very much. Don't forget to fill in your surveys.